All right, now let's look at part C. We have a simple utility function, just a linear function x. So what we have over here is a one-game problem. So we have the following. We have maximization, and x is between 0 and a, right? And we have, if we win, then we have a plus x. If we lose, then we have 1 minus p and a minus x, right? And we have this function f of x is p of a minus x and plus 1 minus p, and here's plus. So we take the derivative, and then we remember taking derivative with respect to x, we have p, and plus 1 minus p. Remember chain rule, we have -1, so we have 2p minus 1. And this is a constant, so we need to look at whether the constant is positive or negative. If it's positive, then the function is increasing. So that means f of a, this one is max. That means we should bet everything. If 2p minus 1 is less than 0, then its function is decreasing. So f of 0 is maximal, right? And that means f x star is equal to 0. So we have the following conclusion. If p is greater than 1/2, equal is also okay, then we should bet everything. And the optimal expected return, v1 of a, is going to be equal to 2p times a. And if p is less than 1/2, we bet nothing. So there is no change to the initial fortune, and then we're still going to be having a. Okay. All right. That's the simple case when the utility function is x. And for part D, now we do the formulation only. So we now have n games to play, but we play the first game first. So we bet x, and to see what's going to happen, and x is between 0 and a. And if we win, then we have a change to the state variable's value, how much fortune we have, and then we have a plus x. If we lose, with the probability 1 minus p, we have a minus x. But we still have n minus 1 games to play. And in the future, we assume we do best. So we will have bn minus 1, a plus x. This is the expected optimal utility for n minus 1 games in the future. And if we lose, we still have n minus 1 games to play, but our initial fortune is reduced to a minus x. And because of the uncertainty, now we have to look at the expected optimal return from future. So expected value is p n minus 1, a plus x, and plus 1 minus p, and vn minus 1, a minus x. This, and maximize over the current action, a x between 0 and a. And this is our vn of a. So this is the one. So this is our Bellman equation over here. And don't forget the boundary condition, v of 0 of a is a. That means if we don't play anything, then we simply have a. All right, last part, we have two utility functions. For log x, it's pretty long, but we can write down the solution over here. Solving it completely, we will see each time we will bet 2p minus 1 of the current fortune. So if the first one is going to be just a, okay? And this is when p is greater than 1/2 or equal to 1/2. And eventually we can show that Vn of A is going to be log A plus n times a constant C. And this C over here is a constant. Okay. And if P is less than 1/2, we don't bet anything. Okay. And because we don't bet anything, then we don't lose any money. So we have log A as the final optimal value. Now, if we have x, the utilities function x, and then we only have two so-called corner solutions. This is going to be either A, if P is bigger than or equal to 1/2, or x1 star is going to be 0 if P is less than 1/2. And for this one, Vn of A, we can show is going to be 2p to the power n A. Okay? And if you don't bet anything, of course, you don't get any increase or decrease of your expected return over there. Okay, that's all. For more details, you can find other videos on this topic. All right, that's it.